हाय, गुड इवनिंग। आज हम लोग कंटिन्यू करेंगे अल्कोहल फिनॉल ईथर्स के डिस्कशन। वी एंडेड लास्ट सेशन विद सम आइडियाज ऑन ईथर्स कैसे बनाते हैं। I'm going to spend some more time on that idea because का रिएक्शन मैकेनिज्म मुझे लगा थोड़ा सा रश था। We'll do that again in the first 5 minutes of this session. उसके बाद we'll finish up ईथर का प्रिपरेशन टेक्निक। दूसरा वाला कौन सा था? विलियमसन सिंथेसिस। Let's open up NCERT quickly. वो करेंगे हम लोग। उसके साथ reactions, chemical reactions of phenols and alcohols. Most likely देखो, what is the alcohol group? It is OH. So दो बॉन्ड टूट सकता है, या तो O या और H के बीच वाला बॉन्ड या फिर C एंड O वाला बॉन्ड। ठीक है, टुडे वी विल प्राइमरी लुक एट द बॉन्ड ब्रेकिंग बिटवीन O एंड H, मतलब प्राइमरली एसिडिटी ऑफ अल्कोहल एंड फिनॉल्स। इन अ वे, एक तरीके से देखा जाए तो उसको हम लोग डिस्कस करेंगे। ठीक है, shall we get started? How you doing? How you feeling? How confident you feel about this? Let me know in chat. I'm going to quickly go and share my screen. You know the drill, right? हम लोग NCERT देख लेते हैं एक बार कि कहाँ पे है, where are we at and where to go from here. So that's what we're going to quickly do right now. 1 second. So you should be able to see my screen right about now. Yeah. All right. F11. Okay. F11. No, F11. Okay. Great. Cool. So this is what we're going to cover. All of these 2-3 pages. Yeah. From here onwards, chemical reactions ये करेंगे. But before we do this, we will यहाँ पे लिखा है clearly कि there's a cleavage of OH bond. It starts off with alcohols being nucleophiles, electrophiles, and cleavage of OH bond. ठीक है, तो हम लोग इसको करेंगे. May seem like just a couple of pages, but we'll go into detail with the mechanisms. And if we have time, maybe we'll look at some more things. Yeah, ये 3 pages. उसके अलावा maybe we'll do this as well if there is time. यहाँ तक तो definitely करेंगे. और ये वाला part, let's see if we have time, we'll do this as well. Maybe some parts of this. But what I want to start off before I do all of this, मैंने आपको जैसे बताया था, is ethers का preparation. One part we've done, ये तो properly कर चुके हैं. दूसरा वाला part, ये वाला I rushed through it, I felt, so I'm going to repeat it a little bit. Okay, Williamson synthesis and all of that. ठीक है, चलो, let's get started with today's session. Let's go. And can you hear me and see me as always? You know, it's good to know if all's good on that front. आवाज and sight and etc. ठीक है, चलिए, let's get started right away. Hey, what's up, Dhruv? What's up? So this is what I was talking about, right? Remember, मैंने बहुत डिटेल में बताया था कि बेंजीन के साथ अगर आप प्रोपाइल क्लोराइड को रिएक्ट करोगे विद AlCl3, you get cumene. What was cumene? ये मिलता है, right? You don't get phenyl propane या फिर propyl benzene. You don't get that, right? इसलिए हमने we devised a way to get propyl benzene or phenyl propane. You had to get क्या था उसको, acyl chloride, not really acyl but acetyl. Okay, let's go with this. You have to get this particular compound specifically, C2H5COCl, और ये CO में एक double bond है. This is what makes sure with anhydrous ClC that you will get this compound अगर आप उसको बनाना चाहते हैं तो. But okay, now this is cumene. ये था थोड़ा बहुत कि भाई ये compound है क्या. ठीक है, फिर उसके बाद we reacted with O2, right? And what you got is cumene peroxide. Till here we are okay. After this reaction mechanism becomes a little interesting. What you do is आप acidic medium में डालो और heat करो, and because that some funky things happen. इसके बाद वाले steps I felt were a little bit rushed. I was looking at the slides, like somebody sees the slides, you're like, what's happening here? मैं सोचा मैं इसको एक एक करके फिर से बताता हूँ. Just take a couple of minutes, okay? So यहाँ पे पानी molecule है, ठीक है, but acid है system में. So H3O plus is what gets formed, right? H plus interacts with water and gives you this species. You could also get H5O2 plus etc. बहुत चीजें आएंगी, बट हम लोग फोकस करेंगे ये जो peroxide का OH है. you'll see मैंने अलग कलर किया है. इसके ऑक्सीजन वाले जो इलेक्ट्रॉन्स हैं that will attack this and hence ये पानी will get out of here. And what comes here and why I'm doing this यहाँ पे is क्योंकि यही चीज, this is going to be responsible for a lot of reactions of alcohols as well. ये मैंने दिखाया कि peroxide में हो रहा है, but alcohols में भी सिमिलर चीजें होती हैं. ठीक है, we'll talk about that in just a minute. But this comes out over here and water now becomes a good leaving group. Okay, now how will this become a leaving group? Leaving group होने के लिए मतलब कि इसके इलेक्ट्रॉन्स इसके ऊपर चले जाएंगे, ठीक है, then water leaves. But if that happens, this will get something like a plus charge. Well, it doesn't. It happens so quickly कि plus charge develop नहीं होता है, but instead ये भाई साहब जंप करके यहाँ पे आ जाते हैं, which is what is the new thing. पूरा फिनाइल शिफ्ट हो जाता है, जो चीज मे बी आप अपने आप प्रेडिक्ट नहीं कर पाते. That's the main reaction mechanism thing here. And look at this. What you get over here is this compound which looks like a ether, है ना? This looks like a ether with some sort of a positive charge. But अभी तक कहानी थोड़ी सी बाकी है, पिक्चर अभी बाकी है, right? There's more water in the mix. अभी तो हमने एसिड वाला वर्कअप किया, and plus charge. Okay, great, but there's water around, so it's going to give its electrons, and what you get is this over here. Now you may be like, okay, अगर पानी ने इसको अटैक किया, इस प्लस चार्ज को, और पूरा पानी का मॉलिक्यूल यहाँ पे लग गया, ऑक्सीजन में प्लस चार्ज जो स्टेबल नहीं है, इफ यू आर थिंकिंग दैट यू आर एब्सोल्युटली राइट. व्हाट वर्क्स विद दिस इज इसके इलेक्ट्रॉन्स देन गो एंड अटैक दिस. I know, it's a bit much, so don't worry. मैंने सब चीज यहाँ पे लिख के दे दी है. You'll see what happens next. Yeah, and water again gets out of here. But water के बजाय यहाँ पे सिर्फ ये, or the power went. There was some beep 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 noise. Anyway, so it's not water that leaves here. Okay, there's a big difference between this step and this step. यहाँ पे clearly पानी यहाँ पे जाता है because it is next to this, and this has a slightly negative charge. This has a slightly positive charge because of this. Okay, ठीक है. Because this has a negative charge, इसलिए it attracts these guys, this whole phenyl group. This is activate, right? It has basically काफी electrons है. Let me just write electron rich. ये species electron rich है, okay? But here's the whole deal. यहाँ पे इस step में पानी does not go away, okay? The only thing that happens here is just the H goes away with this electron, and यहाँ पे H इधर आ गया. So now what you've got is a protonated hemiacetal, जो मैंने आपको last time बताया था. What is a hemiacetal? A species जिसमें दो चीजें हैं. एक तरफ कार्बन में लगा है OH ग्रुप, दूसरी तरफ लगा है ether. So if you got ether and you've got alcohol on the same carbon, then this is called a hemiacetal. और protonated क्यों? क्योंकि extra H plus आ गया. Again, not very stable, right? पानी 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 पानी, बहुत पानी है. Now this guy will remove this hydrogen over here, and what you get is the final product, which is this right here, phenol and acetone and वापस acid. So after a lot of, yes, thank you Rohit. Rohit is awesome. Rohit figured it out. छोटा से यहाँ पे लिखा हुआ है, right? This is mainly for your notes because I don't think this reaction mechanism in NCERT also may not be necessary for JEE or NEET, maybe for JEE Advanced. पर मुझे लगता है कि मैकेनिज्म अगर ठीक से पढ़ लें तो आपको हेल्प करेगा, क्योंकि ये बाद में in the next chapter, which is aldehydes, ketones, carboxylic acid, I feel this will be useful over there because you do deal with acetals and hemiacetals and all of that. Okay, चलो, here's a quick question आप लोग के लिए. अगर ये रिएक्शन है ROH plus ROH और मैंने यूज किया concentrated H2S4 हीट किया, okay, and I'm getting an ether. ये अल्कोहल कौन सा होगा? What do you think? Can you tell me? This is the last thing I taught you, by the way. Yeah, class के में teach किया था. Just give me a second. I'm going to turn off the UPS that's powering my desktop. Answer this question. I'm going to go away from the screen for like 10-15 seconds. Please answer this question. A, B, C or D. Rohit, Dhruv, what do you guys think? Easy one. Please सोच के बताइए. Okay, I'm back. I know, I told you 10-15 seconds. It's been 10-15 seconds and I'm back. Okay, ये species, the only reason ether बनता है और dehydration होता है and not the whole thing. It doesn't give you an alkene. अगर हम लोग इसको tertiary use करें, it will definitely give you an alkene. Why? What kind of process is this? Elimination. Yeah, right. That's what happens. But instead हम लोग यहाँ पे अगर ether बनाना चाहते हैं, then this has to be a primary alcohol. This is what I taught you last time. If you want NCERT में भी यही चीजें हैं, you can check it out. All right, cool. एक और question. इनमें से कौन से alcohol will give you the best yield of dialkyl ether on being heated with a trace of sulfuric acid? Okay, heated मतलब not too much. 413 Kelvin, not 443 Kelvin. 443 Kelvin will lead to elimination. 413 Kelvin पे हम लोग करें and थोड़ा सा acid डाल दें catalyze करने के लिए. Dialkyl ether. Dialkyl ether मतलब a symmetric ether it looks like. Yeah, we're trying to get a symmetric ether. तो इनमें से कौन सा substance will give me a good yield of dialkyl ether? Well, यहाँ पे भी idea similar है. देखो, cyclopentanol. This is a tertiary carbon. Is it tertiary? Secondary है. Yeah, this secondary carbon है. 2-methyl 2-butanol. 2-methyl 2-butanol. ये तो tertiary carbon हो गया. So this is going to definitely go to elimination, right? ये secondary है. Pentane 2-all. 1, 2, 3, 4, 5 2-all. This is also secondary. The only one that's a primary alcohol is this. Hence the answer should be A. फिर से. Let me fix that. It should be D. That's such a funny typo. Hold on. This is slide number 16, solar. Okay, let me fix that typo. But you get that, right? Why is it that this is going to be, oh wow, this is great. This is going to be fun to correct. T, let's just, I know it's not yellow, but it's okay. We'll live. है ना? एक minute, let me just color that to the right. Specs over here. Okay, yes, D it is, pentanol. Same idea फिर से हम लोग पूछ रहे हैं. Okay, let's move on to आज का theory, which is Williamson synthesis. Yes, Joel, Rohit, good job. It was pentane 1-all. Yes, absolutely. Williamson synthesis is interesting because अब जो issues थे वो heat करने वाले चक्कर में all of them get sorted over here. What we do is we take one methyl halide, let's say alkyl halide. We'll take one alkyl halide. Okay, let me not spoil it for you, right? We can make both symmetrical and unsymmetrical ethers by nucleophilic substitution reaction. Well, that's the mechanism. What is nucleophilic substitution? You know, Rx plus some nucleophile. And what do we do? Some solvent will give me this. Which nucleophilic is good, do you think? SN1, SN2? What do you think is better? We'll see. So, I'm taking a strong base. RONA. Okay, that's a strong base. Why is it a strong base? Dekho, ROH is weak acid, but that's why RO minus is a strong base. So I've got a strong base and I've got an RX along with it. So this is a nucleophilic reaction substitution. But is it SN1 or SN2? What do you think? Strong base. Strong base matlab must be SN2, right? Okay. Yes, thank you, Rohit. You're awesome. Hey, badhiya bhai tum. Hey, that's the nice photo. You got a photo of Ganeshji there? All right, that's cool. That's cool. His birthday is coming up, isn't it? And so is Lord Krishna's birthday. That's coming up. That's next Monday. This coming Monday. So इससे बन जाता है ether. And if you've been paying attention to my haloalkane classes, that was the first thing we did. Haloalkane में SN2 का पहला reaction यही था. हम लोग उसमें लेते थे CH3OH और react करते थे with something else, with like some RX, and you'd get the same thing. You'd get this. Anyway, and you get NaX, the salt along with it. This is SN2 reaction. Alkoxide इसको बोलते हैं, ठीक है? The thing is, ये जरूरी है, the substrate must be unhindered. Substrate मतलब क्या भाई? इसको बोलते हैं substrate. कहाँ गया? ये है हमारा substrate, ठीक है? ताकि न्यूक्लियोफाइल उसको जल्दी से अटैक कर सके. This is kinetically limited. मतलब क्या होता है? Kinetically limited मतलब कि ये जल्दी हो जाता है ये reaction. Okay? You don't give it enough time to form carbohydrate and all that. Nucleophile तुरंत अटैक कर लेता है because strong and all that is unhindered. So your solvent needs to not be protic or polar. वो सब है, यहाँ पे solvent लिखा नहीं है, but all that you've studied in SN2, right? ताकि इसको solvent और न करे, आराम से nucleophile को जाने दे. Okay. But we're talking about substrate. Substrate must be unhindered, मतलब primary or secondary होना चाहिए, not really tertiary. Yeah, it's not good. So primary better than secondary, better than tertiary. This is a recap of SN2 में क्या होता था. And you should have a good leaving group. यार, हाँ, X is a good leaving group. OH is not a good leaving group. Okay. X is a great leaving group. I डाल दो, iodine डाल दो, it's a good leaving group. So this is the overall mechanism. Simple चीज है. Okay. So if I give you this, say for example, what is the product of this? What do you think is the product of this reaction? Here's my weirdly hindered base. It's pretty hindered. And this is my substrate. Okay. So क्या होगा? इसके पास इलेक्ट्रॉन्स हैं. इसके पास इलेक्ट्रॉन्स हैं. ठीक है. ये बॉन्ड टूट जाएगा, इसको प्लस चार्ज यहाँ पे आ जाएगा. So this will attack this, right? Just quickly doing this while you tell me if you agree or you disagree, right? There's going to be no rearrangement and all that सब नहीं होगा because SN2 reaction है, ठीक है? So don't do things like, hey, you know what, hydride shift होगा and this get a plus. No, that's not going to happen. None of that's going to happen. ठीक है? पहली बात, bond यहाँ टूट रहा है, ठीक है? Please don't do random thing like that. I know you may be tempted to, but don't do it, right? Bond कहाँ टूट रहा है? This is the bond that's breaking. So you got all of this with the O, which is this right here, right? यही चीज मैंने यहाँ पे देखी, देख लो, सेम चीज है. 1 2 3 4 carbons. So 1 2 3 4 carbons, and the third carbon पे है substitution, which is this methyl right here. And बगल में क्या है? Ethyl group. That's it. This is the answer, right? You want to name it? You can go ahead and name it. Agreed? Okay, great. Great. Your students are awesome. You want just an exercise, नाम दे दो उसको, ठीक है? To synthesize tertiary butyl methyl ether. Tertiary butyl methyl ether. इसका मतलब क्या हुआ? देखो, जो छोटा वाला ग्रुप है वो बाद में आ जाता है, ठीक है? टर्शरी ब्यूटाइल, टर्शरी ब्यूटाइल 1 2 3 4 ओके कूल 4 कार्बन है। ये बनाने के लिए what do you take the starting material? Do you take the starting material as tertiary butyl halide and methoxide ion? मतलब कि MEONA plus tertiary butyl halide. This does that work? You already know the answer. It does not work. We have told you, boss. This is a tertiary substrate. Tertiary substrate does not prefer SN2 reaction. That will go by SN1 reaction. और अगर SN1 reaction होगा तो this is going to form an alcohol. It's not going to form an ether. है ना? That's not going to happen. And also it's got a strong base. So anyway, खैर. So tertiary butyl halide और methoxide ion अगर उसको reactants करो तो elimination हो जाएगा and ether नहीं बनेगा. ठीक है? That's clear. Yeah, good. Absolutely. Yeah. Because again, tertiary alkyl halide is goes through the elimination product, not really SN2. SN2 does not happen. That prefers primary greater than secondary greater than tertiary. So you would see that हम लोग जो भी ऑर्गेनिक केमिस्ट्री में कर रहे हैं, you need to be really good at that whole SN1, SN2, E1, E2. हाँ, हम लोगों ने हैलोएल्केन्स किया, अभी अल्कोहल्स फिनॉल रिसर्च करें, यहाँ पे फिर से वही चीज आ रही है. So if you have any confusion, that please go and rewatch my sessions if you haven't done that already. या फिर मास्टर ऑर्गेनिक केमिस्ट्री साइट पे जाइए. From there you can get clear cut comparison between substrate, nucleophile, solvent, सब चीज का SN1, SN2, E1, E2. Okay, so this is the more relevant thing. Okay, so what we'll do is sorry, this is not a relevant thing. इसमें तो elimination होगा, right? Why will elimination happen? Because first of all, this chap's slightly negative. Huh? Okay, what is going to happen is this guy goes here. You get a kind of a positive charge over here. Okay, and what you're going to get is ये इसका hydrogen निकालेगा. Okay. And that negative charge is going to, well, get out of here and it gives you an eliminated product. So this is E2. Yeah, that bracket got skipped. So that's not a good thing. You don't want this. What do we want? We want to produce the other guy. So what do you take? Well, simple सी बात है. जो sterically hindered चीज है, उसमें put an O minus over there, okay? And the substrate needs to be not sterically hindered. So if you're going to use Williamson synthesis, यही Williamson synthesis है. Less hindered alkyl group should be on the alkyl halide, which means the substrate. More hindered alkyl group should be on the alkoxide. Alkoxide मतलब nucleophile. Same अगर language use करें तो वहां पे. तो इसको बनाने के लिए starting materials होने चाहिए methyl halide and tertiary butoxide ion, which is this right over here. ठीक है? And then this is going to undergo SN2. That's it. You're done. Yes, sir. Yes, Rohit. बिल्कुल सही बोला आपने. Okay, so now we can also prepare aromatic compounds like this. So अगर मुझे alkyl phenyl ether बनाना है, so I need to use phenyl is pretty big. So I have to use the phenoxide ion. There is no option. You must do phenoxide. Right? It is not. Can I do this? Can I do that? No. Phenoxide has to be used. ठीक है, with alkyl halide. So here you go. Phenoxide, alkyl halide. पहले phenoxide कैसे बनाओगे? You have this, you react with NaOH, right? Strong base and you get phenoxide ion. And then RX. You get the ether that you want. Okay, so I've got another funky thing. इसमें क्या होगा product? By the way, do you remember हमारी conversations about हम लोगों ने बात की थी क्या इसके बारे में? I don't remember completely, but anyway, we'll talk about it now if we haven't spoken about it before. What is the point of this group? What does this do? What does NO2 do? NO2 क्या करता है? नाइट्रोजन इलेक्ट्रोनेगेटिव है, बट ऑक्सीजन भी उससे भी ज्यादा इलेक्ट्रोनेगेटिव है. So nitrogen kind of becomes plus. So it pulls electrons, yeah. So nitrogen is pulling electrons. Electron withdrawing group EWG रोहित ने लिखा, बहुत अच्छा लिखा. EWG वही इलेक्ट्रॉन की तरफ खींचता है. कहां से? इससे. So it's going to be pulling electrons, destabilizing the ring. That's awesome. That means it's stabilizing this negative charge. अगर इसको स्टेबलाइज करता है तो ये रिएक्शन और भी ज्यादा जल्दी होगा. कौन सा रिएक्शन? ये वाला रिएक्शन. या माइनस आई प्लस आई जो भी है वो सब याद कर लेना वाला. मेन चीज है इलेक्ट्रॉन विथड्रॉइंग ग्रुप. ठीक है? दिस नेगेटिव चार्ज, आई मीन दीस इलेक्ट्रॉन्स गोना अटैक दिस गाय, एटसेट्रा. दिस इज द प्रोडक्ट दैट यू गेट. ओके, कूल. सो अ क्विक क्वेश्चन जस्ट टू सी, जो लोग अगर देख रहे हैं वो सोए हैं कि जगह हैं. Williamson and synthesis of ether is an example of which of these things? Nucleophilic addition, electrophilic addition, electrophilic substitution, nucleophilic substitution. देखिए, when you're studying, तब तो सब याद रहता है. But if this question is thrown at you in a test, then you'll be like, what is a nucleophile? What is an electrophile? होता है, कभी-कभी होता है, anxiety में or whatever you want to call it. So yeah, Maybe you'll be able to answer it right now, but the goal is test में answer करना. So how do you identify क्या हो रहा है? What is happening here? You have an RO minus group and you have RX. Okay. अगर मैं इसको बोलूं न्यूक्लियोफिलिक एडिशन को हटा देते हैं, बिकॉज एडिशन हैज टू डू विद अ डबल बॉन्ड पे ऐड करना. नो, सो इट्स ईदर इलेक्ट्रोफिलिक और न्यूक्लियोफिलिक सब्स्टिट्यूशन. इलेक्ट्रोफिलिक सब्स्टिट्यूशन मतलब कि समथिंग दैट लाइक्स इलेक्ट्रॉन्स, मतलब इट मस्ट बी पॉजिटिवली चार्ज. यहां पे तो कुछ पॉजिटिवली चार्ज चीज दिख नहीं रही है. यू कैन काइंड ऑफ आर्ग्यू कि देखो ये चला जाता है प्लस चार्ज तो ये हो गया इलेक्ट्रोफिलिक एडिशन, बट नो, दैट्स नॉट द डील. दिस न्यूक्लियोफिलिक सब्स्टिट्यूशन. ओके, वी हैव जस्ट डन दिस. SN2 मैं बोल रहा हूं कि अगर गलती से एग्जाम में भूल गए completely, you're like completely sidelined, like what is all happening, I don't remember anything. That's how you go through the options and still figure it out. ठीक है, I know you know the answer to nucleophilic substitution because that's what we've done in the last 5-10 minutes. But अगर गलती से ये सोचना हो इलेक्ट्रोफाइल मतलब something that likes electrons, so it must be positive. यहाँ क्या positive है? कुछ positive है ही नहीं. RO minus is there, right? So anyway, yeah, all right. So इस कंपाउंड को अगर बनाना है मुझे, मतलब कि टर्शरी ब्यूटाइल ही लग रहा है, और उसके बाद टर्शरी ब्यूटाइल के बाद ये तो बहुत बड़ा सा है. ये क्या है? Oh, phenyl. Oh, toluene kind of a thing, right? You got methyl benzene sort of a thing. How do you name this? I'm not good at naming things. Dhruv, all right, good. Thanks for the answer. Figure out the name for this. But इसको हम लोग विलियमसन सिंथेसिस से कैसे बनाएंगे? ये दोनों लग रहे हैं स्टेरिकली हिंडर्ड. क्या करें? देखो, स्टेरिकली हिंडर्ड और बल्कि में थोड़ा सा फर्क है इन अ वे. स्टेरिकली हिंडर्ड मतलब कि स्पेसिफिकली जो न्यूक्लियोफाइल अटैक कर रहा है, राइट? इट्स अ न्यूक्लियोफाइल दैट गोज एंड अटैक्स अ सबस्ट्रेट. सो सबस्ट्रेट को स्टीयरिकली हिंडर्ड नहीं होना चाहिए. श्योर, इफ इट इज प्लेनर दैट्स नॉट अ प्रॉब्लम. सो लाइक हियर अगर मैं सबस्ट्रेट लो टू बी दिस, राइट, जस्ट गोइंग थ्रू द मोशन, कहां पे अटैच करेगा? वेल, इट्स अटैचिंग हियर, राइट? It's going to attach here, so that's all right. I'm not trying to attach it here or here or here. That would be a little scary. But मैं इस ग्रुप पे अटैच करने की कोशिश कर रहा हूँ, which is not that big a problem. You know, that kind of works. So I could have this as my substrate. ठीक है? But whereas अगर मैं इसको compare करूँ with this, that's a no-go, right? This is a tertiary X. That's not happening. That's bad. So I'm going to be using this as my, what should I call it? My nucleophile, है ना? A लगता है ध्रुव को देखना है. यार ध्रुव, अच्छा BB, यार तुम्हारा BB थोड़ा सा A जैसा दिखता है मुझे. ध्रुव is saying B. All right, let's see. So ये नहीं है because as I said this is bad. This is just what I don't even know what this is. No. Oh, okay, interesting. Really? No, that's just C is so confusing, but definitely not. B is the answer. Yeah, बिल्कुल सही बोला आपने. Yeah, absolutely. Good job. Another question. Yeah, Dhruv, thank you. Rohit, bilkul sahi. The formation of diethyl ether from ethanol is based on what? Diethyl ether. Matlab, like the bat. Is it a dehydrogenation? Hydrogen से निकल रहा है नहीं. और hydrogenation reaction, dehydration reaction या heterolytic fission reaction. What is heterolytic fission? You've got Cl2, it becomes Cl plus Cl minus in the presence of AlCl4. I can call that as a heterolytic fission, sort of. But anyway, this one it looks like it's dehydration. आपको क्या लगता है? Dehydration ज्यादा है कि पानी पीना चाहिए, right? पानी निकलता है, एक जगह से OH निकल रहा है, दूसरी जगह से H निकल रहा है, hence dehydration. तभी तो बनता है ether. Yeah, absolutely. Oh, someone saying A? Okay, Kim changed their answer. ध्रुव को भी A लग रहा है. हाँ. Okay, we'll have to discuss this a little bit then. मुझे तो लग रहा था C, but ठीक है, एक बार फिर से बात करते हैं. I'll show you how dehydration. देखो, if I take this whole, ethanol. This is ethanol. फिर मैंने डाला acid और heat किया. Acid क्या करता है? Acid इसको निकाल के ले जाता है. किसको निकाल के ले जाता है? Well, in fact, ulta way around, yeah. This oxygen attacks this. It's got a couple of electrons over here. ये acid पे attack करता है. Acid के H पे attack करता है. This forms this. Okay. This is a nice leaving group. And then you've got this guy over here. तो ये attack करेगा इस पे because now there's a delta plus and a delta minus over here. Okay. Cool. This is a good leaving group. OH is a bad leaving group, but OH2 plus, that's a good leaving group. ठीक है? Hence you get this whole compound right here. तो यहां पे निकल गया पानी साथ में, ऑलराइट। एंड अगर ये फिर से प्लस बचा है तो क्या करेंगे? वेल, ये इसका इलेक्ट्रॉन्स ही इस पे अटैक करके इसको ले जाएंगे, बिकॉज एसिड कैटलाइज्ड है, राइट। सो यू गॉट H3O प्लस। आई नो निकल रहा है पानी, बट ऑल्सो दैट H प्लस दैट वी यूज इनिशियली, राइट, दैट reacts to the water gives you H3O plus. If you do not remember this, हम कर चुके हैं, but ठीक है, no mind going over this again. Reaction mechanism करने में मुझे तो आता है मजा. You guys also should enjoy it. तभी तो you like organic chemistry, otherwise it can get very muggy. Yeah, Rohit, Dhruv, and Joel, you guys are right. Kim, I hope you've also understood this one. Okay, cool. Let's move on to the second part of this reaction, this session, reaction of alcohols and phenols. Ether बाद में करेंगे. आज हम लोग will focus on the specific one type of reaction, which is, well, alcohols can behave दोनों, nucleophile, electrophile. इलेक्ट्रोफाइल, न्यूक्लियोफाइल तो समझ में आता है ना, बिकॉज इसके पास इलेक्ट्रॉन है। इलेक्ट्रॉन अगर अटैक करे तो न्यूक्लियोफाइल, न्यूक्लियोफाइल मतलब न्यूक्लियस लविंग, मतलब इट लाइक्स पॉजिटिव थिंग बट मस्ट बी नेगेटिव, सो इट बिहेव लाइक अ बेस बेसिकली, राइट, है ना। इलेक्ट्रॉन अगर दे रहा है बिहेव लाइक अ बेस। इलेक्ट्रोफाइल मतलब इट लाइक्स इलेक्ट्रॉन्स, मतलब पॉजिटिव चार्ज। ये इंटरेस्टिंग है, ये कैसे होता है, विल सी। दिस वन इज इजी टू अंडरस्टैंड, दिस न्यूक्लियोफाइल बिजनेस, राइट। इफ इट बिहेव्स लाइक अ बेस, मैंने यहां लिखा था ना बेस, इट बिहेव लाइक अ बेस, मतलब विद एन एसिड इट कैन रिएक्ट, है ना। तो दिस इज एन एसिड बेस रिएक्शन, ओके, हो गया न्यूक्लियोफाइल, दिस इज सिंपल। बट इलेक्ट्रोफाइल कैसे बने? न्यूक्लियोफाइल इज चिल, राइट, हाउ इट बिहेव लाइक अ न्यूक्लियोफाइल इज ओके। एक्चुअली इसी में हिडन है टेक्निक। अगर ये हो गया, देन द नेक्स्ट स्टेप कैन बी गुड लीविंग ग्रुप, लेट्स गो, right, and that is in a way electrophile, because अगर ये चला गया तो this gets a plus charge. Ooh, electrophile plus charge, awesome, great, right, इसके इलेक्ट्रॉन चले गए यहाँ पे। So let's see electrophile कैसे होता है। ये हम लोग को पोलराइज करना है CO बॉन्ड को, right, and it makes it kind of positive. अगर OH माइनस नहीं होता then that will be good to nucleophilic attack, but how do we make it a good leaving group? Well, you attack with an acid, ठीक है, to allow substitution elimination reactions. तो acidic इसमें हम लोग OH minus से we make it H2O to be a good leaving group, specifically OH2 plus, उसके बाद वो प्लस चार्ज चला जाता है कार्बन पे, which means it becomes an electrophile. So see, the same thing जो मैंने acid का किया था, but now we're going to focus on that second thing, like that guy right there, not this but that. Okay, so that now is a good electrophile. थोड़ा सा और बाकी है, पिक्चर थोड़ी सी बाकी है यहाँ पे। Okay, प्रोटोनेशन के बाद ये कार्बन एटम और भी ज्यादा पॉजिटिव आता है, क्योंकि OH2 is more electron withdrawing than OH, making it susceptible to nucleophilic attack, ठीक है। So SN1 SN2 हो सकता है डिपेंडिंग ऑन किस टाइप का अल्कोहल है। अगर टर्शरी है तो SN1 प्रेफर करेगा, अगर प्राइमरी है तो SN2 करेगा, एटसेट्रा एटसेट्रा एटसेट्रा, ठीक है। व्हाट एम आई टॉकिंग अबाउट? हियर यू गो, OH2 प्लस है, ये तो निकलना चाहता है, दिस वांट्स टू गो। इफ इट वांट्स टू गो, two things can happen. Now this is an SN2, अच्छा लिखा already, SN2 reaction. Again, this is only if you got primary or maybe secondary, not tertiary for sure, right? एक स्टेप का रिएक्शन हो रहा है, और the other goal is कि भाई हो जाता है tertiary हो तो फॉर्म ऑफ कार्बन कैटायन विद SN1, एंड ये दोनों बॉन्ड्स पोलराइज्ड हैं, ओके। बट यूजुअली यू थिंक अबाउट दिस पोलैरिटी, नॉट सो मच दिस पोलैरिटी, बट स्टार्ट थिंकिंग अबाउट दिस पोलैरिटी एज वेल, ओके। ये भी है पोलर, राइट, CNO का बीच में पोलैरिटी है, of course ONH के बीच में ज्यादा पोलैरिटी है, which is why you think about that more, right, but this also exists. So ये दोनों ही चीज हम लोग यहाँ पे पढ़ेंगे, एक तो क्लीवेज ऑफ OH बॉन्ड या फिर क्लीवेज ऑफ CO बॉन्ड। In today's session we'll try and cover this entirely, टाइम मिले तो we'll do a little bit of CO bond as well. So cleavage of OH bond तो ऐसा लग रहा है कि this will behave like an acid, right, this is going to behave like an acid. अगर H चला गया, if it's giving off H plus, then it becomes O minus, then looks like it's behaving like an acid. देखते हैं, yeah. So if this is confusing you, it should not, right? मैंने पहले बोला था behave like a base. If it behaves like a base, that was ROH plus H plus, right? That gave me ROH2 plus. This is behaving like a base because it's accepting H plus. But now I'm saying कि ROH will react with say a base and it gives me RONA. This is it behaving like an acid. Yeah, cool, because it lost an H plus, that's it. Okay, ठीक है, and this is why we're going to talk about acidity of alcohol phenols, and the second part is esterification. Acid की तरह behave करेगा तो acidity की बात करते हैं, ठीक है. And maybe you already know this, but we'll go over it a little bit more. Alcohols are not acidic. Like, it's, what are you talking about, right? Alcohols are very, very mildly acidic. इसीलिए उसका conjugate base RO minus is very, very basic. ठीक है ना? देखो, अगर कोई चीज weakly acidic है, उसका conjugate base बहुत ज्यादा strongly basic होगा. This is fine, right? There's no doubt in this. If I write ROH, and this gives me, like, say, double-headed arrow लगा देते हैं because it's not very strong. If it gives me RO minus plus H plus, then if I'm saying कि this इसका pK value say 16, this इसका pKb value is going to be like -2, right? Because pKa plus pKb must be equal to 14 of क्या? Conjugate acid, conjugate base pair. ये सब याद है? ये सब याद है? Do you remember all this from ionic equilibrium? Please give me a quick thumbs up if you remember this from ionic equilibrium. This is slightly important, okay? At the level of JEE main and NEET, you probably don't need this, you don't care. But JEE advanced के लिए this is like the single most important thing. I feel कि कौन सी चीज acidic होती है. And actually even JEE main and NEET के लिए conceptually speaking this makes sense, right? This is fine, ना? इसलिए हम लोग उसको use करते हैं on day-to-day things. When I tell you that aromatize is strong base, why is it strong base? Because of this. Okay. Anyway, so दोनों alcohol or phenols they release H2 gas on reaction with sodium or potassium and other alkali metals. मतलब कि acidic hydrogen exist करता है. इस अंग्रेजी का मतलब क्या हुआ? इसका ये मतलब हुआ कि ROH plus Na gives me RO minus Na plus and H2 minus Na plus and H2. But between these two, ये है ज्यादा acidic. Okay. Why is it more acidic? अगर आपको 11th standard की थोड़ी सी chemistry याद है, you already know the answer. But if not, we'll recap it. हम लोग देखते हैं, ठीक है? Quick question दो. Aluminium के साथ क्या होगा? सोडियम पोटेशियम बताया था. एल्यूमिनियम के साथ क्या रिएक्शन होगा? Well, it's no big deal. It's just a trivalent atom. So it'll require 3 of these guys. That's it. Okay. अगर आप इसको बैलेंस करना चाहो, yeah, it's already दिया हुआ है. Okay. ये मुझे नहीं देना चाहिए था, but ठीक है. If it says 6 over here nicely already, plus 2 of this, it's going to give you this, right? That's it. And 3H2. So हो सकता है, maybe JEE main में आपको पूछा जाए, if this is possible, right? Hey, how many liters of hydrogen is released when you react, say, 54 grams of aluminum completely with some compound? I'm like, what? That's how you do a question like that. I can make a question. That's a valid question. That's a nice question. It may seem like a physical chemistry question, but unless you know क्या होता है organic chemistry, you can't proceed with it, right? That's a possibility. That's a possibility. Okay. Acidity of alcohols and phenols. Yeah, we want to talk about this. Polarization of the OH bond. अगर polarization ज़्यादा है, पोलराइजेशन ज्यादा है. हाँ, पोलराइजेशन ज्यादा है. अगर पोलराइजेशन ज्यादा है तो एसिडिक होगा या कम एसिडिक होगा या ज्यादा होगा? व्हाट डू यू थिंक? जस्ट एन इनपुट. पोलराइजेशन अगर ज्यादा है, इफ द पोलराइजेशन इज मोर, इज दैट गुड और इज दैट बैड? सो व्हाट्स अ गुड एसिड एनीवे? अ गुड एसिड इज OH बॉन्ड थोड़ा वीक हो जाना तो अच्छा है. मतलब द बॉन्ड शुडंट बी टू स्ट्रांग, आसानी से टूट जाना चाहिए. मतलब अगर वो बॉन्ड आयोनिक हुआ दैट्स द बेस्ट, बट आयोनिक के जितना क्लोज हो गया उतना अच्छा है. ओके, कूल, ग्रेट. सो व्हाट मेक्स HCl सच अ गुड एसिड? द फैक्ट दैट Cl माइनस बहुत स्टेबल है, बहुत चिल है, इसलिए HCl तुरंत H प्लस तोड़ देता है. मतलब कि अगर RO माइनस किसी तरह स्टेबल हो गया तब ROH अच्छा एसिड होगा. यू आर गुड विद दैट आइडिया, राइट? ये आइडिया ठीक है. ये सब आयोनिक इक्विलिब्रियम के आइडियाज है, बट धीरे धीरे इसलिए बार बार बोल रहा हूं. So, how do you compare the acidity of alcohols? सिंपल चीज ये बन गया. अगर स्टेबिलिटी अल्कोक्साइड की ज्यादा हो गई तो एसिडिटी ज्यादा हो जाएगी, राइट? ओके, कूल. अगर if I've got a sterically hindered alcohol, like say a tertiary alcohol, tertiary butyl alcohol, ये कम एसिडिक होगा than unhindered alcohol. Why is that? Because all of these groups they push electrons into this carbon. ठीक है? You want things that pull electrons away. अगर ये electrons को push कर रहे हैं, इसको क्या बोलते हैं? Electron donating groups, EDG, right? That's what you guys write in coaching lingo. तो अगर ये methyl groups हैं, ये electron को push कर रहे हैं into the system, right? They don't want electrons. Like ले लो भाई, ले लो, right? So if they're giving electrons away, that's making this unstable. क्योंकि they're increasing the negative charge. You want to decrease the negative charge to make it stable. ठीक है? So unhindered alcohols such as this or this, ये ज्यादा acidic होंगे as compared to this. बट ये तीनों ही बहुत कम है. दे आर बैड 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 एसिड. आई विल शो यू हाउ बैड विद सम नंबर्स. ओके, अगर कोई अनहिंडर्ड अल्कोहल है तो पानी मॉलिक्यूल्स को आसानी से, थियोरेटिकली रिलेटिवली आसानी से सॉल्वेट कर सकते हैं, हेंस मेकिंग इट स्टेबल. ठीक है. एंड जो मैं चीज बार बार बोल चुका हूं, जो कॉन्जुगेट बेस अगर आसानी से बन रहा है तो एसिडिटी उसकी बढ़ जाएगी. आसानी से बन रहा है मतलब मोर स्टेबल कॉन्जुगेट बेस. सो दिस इज द डील, राइट? इलेक्ट्रॉन डोनेटिंग इन नेचर, which is why the acidity of primary is greater than secondary, third tertiary. Okay, अगर acidity ज्यादा है, what is this amazing? अगर acidity ज्यादा है, what will happen to the pK values? This is okay ना? pK values उल्टा हो जाएगी. pKa 1 is maximum होगा pKa इसका, pKa 3, right? Yes sir. The class you would hear can screen that out, but you can't. This is all right. Give me a quick thumbs up. This is fine. pKa is ulta of acidity order. This is cool, right? Please understand this. Bro, what is pKa? कुछ याद है? क्या होता था Ka? Ka was a measure of how good a reaction proceeds forward. Specifically, acid की बात हो रही थी. pKa क्या था? Negative log of Ka. ठीक है? Don't see stars now. This is important. I want you to be able to see pKa and H+ और उनके बीच में क्या चीजें, because if you look at any data on organic chemistry, सब जगह यही दिखता है. ठीक है? This is what you look at. They tell you the pKa values, and I'll also discuss it. They'll come in right now. So alcohols की acidity is so low that is similar to that of water. Methanol is like slightly strong acid than water. What do you mean? This acidity of water pKa is 15.74. You're like, wait a minute. No. KLW is supposed to be 14. What is this pKa being 15.74? See, yeah, theoretical. This is the real deal. And that, by the way, is pKw's concentration of H+ into OH-. This is slightly different. Okay. Why this 15.74, please, is beyond the scope of our discussion right now. But if you want to talk about it, it's a beautiful question. We'll do that on Telegram or on Discord. You can ping me. My ID is I Teach Chem. I run Discord servers and Telegram servers. You can come and ask me there, or you can even better, you can read it up. Yeah, if you want to know what is this scene of 15.74. So I said that methanol is more acidic. क्यों? क्योंकि इसका pK value is lower. pK value is lower, so more acidic. And you can clearly see कि least acidic है ये, जिसका pK value 18 है, which is like, you don't even think about this, right? See, organic chemistry and these are okay, but in real, like, normal acids and bases वाली बात जो हम लोग कर रहे थे, which is CH3COH, just to give you a frame of reference, इसका pK value 5 थी. You remember that? 4.74. If you've done a lot of organic chemistry, if you've done a lot of physical chemistry questions, maybe you'll remember it. 5, 4.74 कुछ तो था, है ना? खैर, let's compare the acidity of phenols and alcohols. मैं बताया, आपको ऑलरेडी पता चुका, phenol is more acidic, but how and why वो अभी देखते हैं. ये है अल्कोहल यहाँ पे, साइक्लोहेक्सेनॉल, और फिर मैंने वहां पे 3 यहाँ पे डबल बॉन्ड ऐड कर दिए, मेकिंग इट फिनॉल इन दैट एज. फिनॉल का pK is close to 10 and cyclohexanol is 18. Did you see that? It's 10 power 8 times more acidic, right? Because if you take pK to be 10 here, if you take pK to be 18, it's 10 power 8 times more acidic, which is really acidic. But like, look, you may be like, bhai, fir bhi 10 hai. 10 does not seem very acidic. 10 is like not acidic at all, but 18 is pretty acidic. Just 1 second. Hey dude, in class, I'll call you after. Yeah? All right. Sorry about that. ठीक है. So, is this okay? Do you understand the difference in order? Appreciate the difference in order कि कितना ज्यादा acidic है ये. इसीलिए उसके reactions कुछ अलग होते हैं. You heard Lucas test, ये वो सब आपने सुना होगा. कोई टेस्ट देता है, कोई चीज नहीं देता है, ये सब सवाल पूछे जा सकते हैं. But what's the deal behind this? It's this acidity वाला idea. ठीक है. Why? Because this guy has a partial double bond character, making it extremely stable. You know the drill, right? इससे ये निकाला, it's got a lot of electrons, lot of electrons, and whoops, this goes here, this goes, इसके electron गए यहाँ पे, and you get like a negative charge here, right? etc etc. We'll see all of that. यहाँ पे कुछ नहीं है, there's nothing stabilizing this. So there are many different canonical forms of that species. Okay, it's reactive. I'm not taking it away from it. Yeah, if you want to do electrophilic substitution reactions, sure, great, awesome. But by itself, it's going to be sp2 hybridized, and it's an electron withdrawing group because of more s character. उसको stabilize कर देता है. And besides that, you've got all of this. ये सब 11th standard की चीजें हैं, ठीक है? We don't go over this in detail, but this is pretty stable. This is pretty stable. Yeah, it's resonance stabilized. This is all right. Yeah, simple. All right. Yeah. What's up, Kirtan? Nice name. And there's no stability of resonance by cyclohexanol. Cyclohex. This is funny. Alkoxide. Cyclohexoxide. That's a tongue twister. Cyclohexoxide. Well, hexanoxide. Nah. Anyway, so रेजोनेंस स्ट्रक्चर्स में नहीं है तो कोई चार्ज सेपरेशन नहीं होता है. सो इसकी वजह से दिस इज प्रीटी स्टेबल एंड अगेन दिस इज फ्रॉम 11th grade and all of that. कूल. सो इस फिनॉल पे अगर मैं कोई ग्रुप्स लगाऊं, हम लोग उसकी एसिडिटी कैसे कंपेयर करेंगे? यहां पे एक समरी दी हुई है, बट यू डोंट हैव टू लुक एट समरी. समरी लिखने से पहले भी मेरे पास फिनॉल है. उस फिनॉल से अगर मैं इलेक्ट्रॉन डेंसिटी कम कर रहा हूं रिंग की, देन इट्स गोइंग टू बी मोर स्टेबल. इलेक्ट्रॉन डेंसिटी कम कैसे करेंगे? ओके, आई कैन जस्ट पुल इलेक्ट्रॉन्स अवे बाय अ ग्रुप लाइक नाइट्रो, और आई कैन आल्सो हैव रेजोनेटिंग ग्रुप्स, राइट, लाइक -m ग्रुप्स. अगेन पुल इलेक्ट्रॉन्स अवे. दोनों चीज इंक्रीज करेंगे एसिडिटी को. दैट्स व्हाट वी हैव सीन. अगर एसिडिटी इंक्रीज करेंगे मतलब pKa वैल्यू डिक्रीज करेंगे. यू विल डिक्रीज pKa, increase acidity. Okay, cool. Now, if I add plus I groups or plus M, they're going to decrease the acidity of phenol, increase pKa. But किस position पे matter करेगा? See, that's why 11th standard की organic chemistry इतनी जरूरी है before you do 12th standard की chemistry. We'll discuss the position वाला effects also. See here, that's the question here. Meta-nitrophenol versus ortho-nitrophenol versus para-nitrophenol. Now, this is a very relevant question from JEE or NEET. This is what's going to actually be asked, right? इन दिनों में से pK वैल्यू सबसे ज्यादा किसकी होगी? What is the order basically? pK वैल्यू का ऑर्डर, ठीक है. अगर आपको pK अजीब लग रहा है तो आप मुझे एसिडिटी का ऑर्डर बता दो. एसिडिटी का ऑर्डर होगा, उसका उल्टा हो जाएगा pK का ऑर्डर. That's it. See, if you get confused between this pK वाला business, you do acidity, and the reverse order of pK is going to be acidity order. Okay, cool. Meta-nitrophenol. So I've got phenol and I've got meta right here. Okay, ortho-nitrophenol. Okay, para-nitrophenol. Now, just at first glance, I feel कि ये भाई साहब imposter है. क्यों? क्योंकि meta, you may be like कि हाँ, अगर मैं नाइट्रो सब्स्टिट्यूट करूं और फिर OH डालूं तो OH इस पोजीशन. यार ब्रो, लिसन, ऑल दैट इज कूल, बट रेजोनेंस इफेक्ट्स हैपन वेयर? स्टेबलाइजेशन कहां पे होता है? स्टेबलाइजेशन होता है इधर, इधर एंड इधर. स्टेबलाइजेशन और बेसिकली रेजोनेंस is at ortho and para positions. Okay, not at the meta position. Sure, meta पे है तो it will pull electrons away, which is great. More, maybe it's going to be more acidic than phenol, right? This is going to be more acidic than phenol for sure, right? Because electron withdrawing group का idea है. But it's going to be less acidic than both of these. Do you understand this? Give me a quick thumbs up. This is okay. It's going to be less acidic than both of these. ठीक है? और इन दोनों के बीच में यार it's going to be close. ठीक है? अभी ऑर्थो और पैरा में क्या करें यार, ये तो डेटा से देखना पड़ेगा. If I were to guess, right? So pK वैल्यू सबसे ज्यादा होगी इसकी. That's what I think. इन दोनों के बीच में अगर देखना चाहोगे, so see there is some hydrogen bonding over here, which is like हाँ ठीक है. इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग, यहाँ पे इंटरमोलिकुलर हाइड्रोजन बॉन्डिंग, तो ठीक है, तो मे बी लुक्स लाइक दिस विल बी लेस एसिडिक. मतलब ऑर्थोनाइट्रोफिनॉल looks like it will be less acidic than this, and that's exactly what it is. But it's really close, bro. Like I'm telling you, it's crazy. See, this one's 8.36 pKa value. That's 7.2. That's 7.1. ठीक है, these are the actual numbers. Now see, you can go with a lot of logic, but at the end of the day, data को देखना पड़ेगा. ठीक है, ऑर्गेनिक केमिस्ट्री में हायर लेवल पे, हाईएस्ट लेवल पे, दैट्स इट, यू गो विद डेटा, दैट्स इट, देयर इज नो अदर आर्गुमेंट देयर. ओके, इस डेटा को देख के वी कैन गो से अच्छा मे बी बिकॉज ऑफ दिस. दैट्स व्हाट वी कैन डू. सो हियर यू गो, ऑर्थोनाइट्रोफिनॉल हैज दैट होल स्टेबलाइजिंग इफेक्ट ऑफ इंट्रामोलिकुलर वाली चीज, राइट, जिसकी वजह से एसिडिटी कम हो जाती है ना. इसका मतलब अगर हाइड्रोजन ऑक्सीजन के साथ बॉन्ड करना चाहता है, मतलब वो टूटना नहीं चाहता है वो, सो इट्स रिड्यूसेस द एसिडिटी ऑफ दिस. सिमिलरली ये इफेक्ट है बिटवीन टू मॉलिक्यूल्स या इंटरमॉलिकुलर हाइड्रोजन बॉन्डिंग के कारण इसकी भी एसिडिटी कम होती है. बट वो सब कहानी के बाद भी दिस इज द ऑर्डर. ओके, हाउ अबाउट दिस वन, हाउ अबाउट दिस पीके वैल्यूज की क्या ऑर्डर होगा इन कंपाउंड्स में? ऑर्थोक्रेसॉल, मेटाक्रेसॉल एंड फिनॉल. व्हाट इज क्रेसॉल एंड ऑल? यू नो क्रेसॉल क्या होता है? मेटाक्रेसॉल CH3OH, फिनॉल है ये, और ऑर्थोक्रेसॉल सेम फंडा है यहां पे, है ना. मेटा ग्रुप, नो रेजोनेंस, इट जस्ट हैज द आई इफेक्ट, इंडक्टिव इफेक्ट इसमें सिर्फ. कौन सा इंडक्टिव इफेक्ट? ये इलेक्ट्रॉन देना चाहता है, ठीक है. So I feel that that's not good. अगर इलेक्ट्रॉन दे रहा है तो बुरी चीज है ये, राइट. तो विच मीन्स कि सबसे ज्यादा एसिडिक होगा ये. Most acidic would be this, which means it will have the least pKa value. Hold on. Yeah. Least pK value. सबसे कम pK value होगी इसकी, right? Yes, मेधा, बिल्कुल सही. Thank you for that answer while I was explaining this. And why is ortho more than meta? Same idea, right? So this is the point that matters, right? Because the negative charge comes here, right? The stabilizing, resonance stabilizing में negative यहाँ पे आता है, तो अगर इसको इलेक्ट्रॉन देगा, yeah. If it forms a plus, see, this is an electrophile that gets attached, right? CH3 is something that likes electrons. CH3 plus goes there. So this is a good spot for it. So this is going, orthocresol is going to be more than meta, more than phenol. And with this guess, look at the actual numbers: 10.29, 10.1, 10, and actually 9.89 tha in what you call it data. But ठीक है, 10 भी चलता है. Another one, ethanol versus paracresol versus metacresol. Now we're mixing things up, huh? Paracresol. एक मिनट, क्रेसॉल OCH3 है ना? Did I mess that up? किसी ने कुछ बोला भी नहीं. एक मिनट, नहीं सही था. अच्छा ठीक है. What is OCH3 called? कुछ और बोलते हैं उसको, रिसोर्स एंड ऑल. दैट्स OH, दो OH. हाँ, anyway, paracresol. Let's be lazy and put that here. Metacresol. Yeah, I'm doing whatever. C2H5OH. This is the worst, like the worst acid, right? So it's going to have the highest, like massively highest value over here. What? Iska 16 tha na, 15.7 or something. Oh no, that was methanol. That was methanol 15.5 tha. This is something else, maybe 16 or so. Okay. And between para and metacresol तो हमने अभी यहीं पे देखा था. Yeah, ortho था, ठीक है, ortho ज़्यादा तो para भी ज़्यादा ही होगा. This is an easy one. You don't have to spend too much time on this. This is it. Yeah. So this is greater than this. That's it. Now, I don't know why I forgot the name of the guy जिसमें OH एक जगह लगा होता है, जिसमें और दूसरे में OCH3. If anyone remembers it, tell me. It's bugging me a lot. Yeah. Thanks, Rohit. Absolutely right. Simple one. Now this इस सवाल के साथ you will finish this. ये पूरा आज this is like the summary of everything we have done so far. This one question. This is cyclohexanol. आ गया. What is this compound called, bro? I can't believe I forgot the name. होता है लाइफ में. And this is paracresol. This is phenol. And this is paranitrophenol. While I Google the name of this compound, because my memory is so awesome. Can you guys tell me the order of pK values? Reverse arrow for this question. Reverse arrow matlab, is it this or this? pK value पूछ रहे हैं, not acidity. Acidity सबसे ज्यादा तो होगी phenol की ना, सबसे ज्यादा होगी इसकी. That's it. If you got one, you got them all. But do you understand it? This is the order, but do you understand this order? Yeah? Yes, Joel, absolutely right. Yeah? One, yeah, it's going to be that, sure. But do you understand the order? Yeah? CH3 over CH3 के बीच में this is much worse because this also has a resonance effect. Yeah, as along with the electron withdrawing thingy. Electron donating, sorry. Resonance dim. Resonance is stronger than the electron donating thing, hence, yeah. ओ रोहित उल्टा बोल रहे हैं. रोहित भाई पैरानाइट्रो का लेस पक्का. लेस? ओ हे जोएल सेड दिस. ये एसिडिटी ऑर्डर है यार, पीके तो उल्टा होगा ना. हाँ, रोहित इज एब्सोल्युटली राइट. जोएल बोल रहा है 1, रोहित बोल रहा है ये. अब क्या करें? पैरानाइट्रो कप, एग्जैक्टली रोहित. सो व्हेन अ क्वेश्चन लाइक दिस कम्स ना, बी श्योर ऑफ वन थिंग कि सबसे कम किसका होगा. As he said, as Rohit said, I like his thinking. He said कि यार सबसे कम तो पैरानाइट्रो का होना चाहिए. बाकी we'll see. Yeah, you are absolutely right. This is like some ridiculous number like 18 or something, right? This was something like 7. So obviously the order is going to be this. ठीक है? Please यार internalize कर लो. Yeah? Cool? Is all right? You guys still haven't told me the name of this compound. What is OCH3 phenol OH called? Is Google going to tell me? Methoxyphenol. Come on, does it not have a? I think let's look at NCERT. It's bugging me a lot. Let's quickly open NCERT because we can, right? That's the fun thing about studying online. Names of ethers. Physical properties. No, I want to know common names. यहीं पे होता ना. अच्छा नहीं, यहाँ पे ऊपर है. Common names of ethers. Oh noes, nomenclature ऊपर चला गया. Wait, nomenclature. Give IUPAC name of final compound. Anisole. कोई तो बताया था यार. Anisole. Thank you for that. Never mind. Okay. Cool. You guys have to. Oops. Not me. आपको याद करना है यार. Here's the question. इनमें से कौन सा कंपाउंड सबसे ज्यादा एसिडिक होगा? Hey Dev, how are you doing? Which of these compounds is the most acidic? इतनी पढ़ाई कर ली. At the end of the day, what's the deal here? This is bad. pKa is this, right? So it's off. What about this? This is also off. ठीक है, it's good. You got some of these guys giving it. No, it's not. It's bad. So it's going to be worse than 18. Looks like. And this is also well, still a primary alcohol. So not good. This is sp2, which is great, and also it pulls electrons away. So sweet. Answer has to be phenol. This is a very easy question. पिछले वाले जो क्वेश्चन थे वो थोड़े एफर्ट लगाने वाले. This is much easier than all of that. Yeah. All right. We have 5 minutes. I think we can cover a little bit of this esterification वाला idea, right? Breaking of this OH bond. Now, esterification आप लोग शायद स्कूल में ऑलरेडी पढ़ चुके हो. Did you use in 10th standard क्या? सोप बनाने का हमने 10th standard में किया था क्या? 3 तरीके का esterification होता है. एक तो एसिड, तीसरा असाइल, दूसरा असाइल क्लोराइड, तीसरा एनहाइड्राइड. ये these two are better ways and this you'll see why. कार्बोक्सिलिक एसिड के साथ आपको एक स्ट्रॉन्ग एसिड भी डालना पड़ता है to catalyze the reaction. And this is a condensation reaction. मतलब कि पानी निकलता है. This is esterification. So here's the simple reaction. It's not very complicated at all. RCOH, acid plus ROH in the presence of an acid. This is a strong acid. ठीक है? If you're mineral acid, समझ लो. Okay. HA. This is carboxylic acid. ठीक है? What you get is this, which is your awesome ester. I know we haven't studied esters right now. Next chapter. This is all right. Yeah. If you have any doubts, please ask me. ये बहुत स्लोली होता है अगर मैं एसिड नहीं डालूं, बट एसिड डालूं तो बहुत बड़ा टेंशन है. एसिड डालना मतलब, dude, acid is very difficult to deal with, especially mineral acids. अगर आपने लैब में देखा है वो फ्यूमिंग होता है, बहुत बहुत ड्रामा होता है यार एसिड को डील करने में, ठीक है. सो दिस इज ओके, लैब में बनाने के लिए एस्टरिफिकेशन ओके, बट इज नॉट द स्मार्टेस्ट वे टू डू थिंग इंडस्ट्रियली, ठीक है, बिकॉज यू गॉट टू ऐड H2 फ्रॉम HCl एंड दैट कुड मेस थिंग्स अप, ओके. फिर भी उसके बाद भी कुछ घंटे लगते हैं करने में. एंड द टू वेज टू स्पीड इट अप इज, एक चीज को एक्सेस में ले लो, सो वन बिकम्स अ लिमिटिंग रिएजेंट एंड डू इट, बट देन अगेन यू गॉट टू, यू हैव, सी देखो, हम लोग देखते हैं रिएक्शन एज A plus B giving C. In nature, if I do limiting reagent, then in the end product I have what I need and I have something else. और फिर मुझे उसको filter करना पड़ेगा, which is a headache. Okay, having anything extra in your product is a headache, whether it is leftover acid or it is this or it is that. ठीक है, and they're all liquids. That's the problem. See, अगर कोई चीज solid होती तो then fine. As a solid bed, you just clean it, it's fine. But they're all liquids, so it's painful. खैर, और दूसरी चीज है कि किस तरह मैं पानी इसमें बना हुआ निकाल लूं. पानी कैसे निकालोगे? दैट्स अ लिटिल बिट कॉम्प्लिकेटेड, ठीक है, दैट्स आल्सो कॉम्प्लिकेटेड, बट या थियोरेटिकली पानी बन रहा है ना. डू यू रिमेंबर, दिख रहा है ना, सी हियर, वी गो बैक, पानी कहां बन रहा था, सी हियर, दैट्स वाटर, H2O, पानी बन जाता है. कंडेंसेशन रिएक्शन, डिहाइड्रेशन, जो बोलना चाहो बोल लो, ठीक है. अब एक बात पूछनी थी आपसे, पानी कहां से निकल रहा है? इससे H एंड इससे OH निकल रहा है, और इज इट इससे OH एंड इससे H निकल रहा है? व्हाट डू यू थिंक, पानी कैसे निकलता है? What do you think? Any inputs? What do you think is more likely? Huh. Did you think about it? सोचा क्या आपने इसके बारे में? देखो, this is an acid, carboxylic acid. This has a pK value of say 5. This has a pK value of say 16. So it is much more likely to form RO minus and this. H from acid and OH from alcohol. ठीक है, देखते हैं. If I do that, I get R plus. Wow, that's interesting. It doesn't matter, to be honest. So it's something for you to think of. अगर मैं ये करता हूं, if I do that, forming R plus is a little bit difficult, don't you think? Wouldn't it be just easier to get H from here and OH from here? Wouldn't that be easier? Think about it. Because RO minus, is incredibly stable. You already know this, is incredibly stable. This is just something. What does this HA do then? इस HA का रोल क्या है? Let's talk about this for a minute, since this is an interesting thing to talk about. It makes sense, right? कि H तो acid से निकलना चाहिए, but then अगर मैं H acid से निकालूं, then I'm forming this. Oh, actually, yeah, that kind of makes sense. Medha, absolutely right. Yeah. Did I confuse you? That was not my intention. I was honestly asking you कि क्यों ये होगा? अगर मैं ये करूं, then RCO minus is pretty stable. Okay. And then I have say R, अगर इससे H निकाला तो R plus बन गया. Like, oh, okay, that kind of works. What do you think? Medha, do you guys agree with Megha, or do you like, no, this is confusing? क्या लगता है आपको? We can do this later on when we do this whole, क्या बोलते हैं इसको, acids में जो करेंगे वहां देख सकते हैं. If you are curious, you can look at it right here. Here you go. This is the mechanism, right? Basically, this has to do with the bond of this guy, right? It's this positive thing that causes things to happen more than anything else. And this acid over here attacks that carbonyl wala thing. You get a plus charge over here. That's the important thing that happens here. Uske baad, this whole guy comes there, okay? So I know this is going to be a little bit confusing, but at the end, water is the leaving group. Okay, it's beyond the scope of what we want to talk about right now, but I've given you the link to it. You can check it out. Okay, and maybe that will help you figure out कि क्या हो रहा है, क्यों हो रहा है, etc., etc. Oops, hold on. Okay, maybe in the next session, come back to me with why is it कि ये जाता है, कि वो जाता है, सोच के बताओ. In fact, maybe in the next slide itself, you'll get to know क्या हो रहा है. I realize this now. Yeah. अगर कोई भी चीज ज्यादा यूज करो तो इट पुशेस दैट रिएक्शन. पानी निकाल सकते हो जो बना था. असाइल क्लोराइड से भी बन सकता है. व्हाट इज असाइल क्लोराइड? RCOCl. इससे भी यू कैन गो हेड एंड मेक एन एस्टर. यू डोंट नीड एन एसिड कैटलिस्ट. Yay! And that's weird, right? You're like, bro, this is cheating. This is cheating because it looks like this is getting rid of the H and Cl, and you get this. which means कि वो जो मेधा वहां बोल रही थी और मैं बोल रहा था बहुत कॉन्फिडेंटली, उससे कुछ अलग हो रहा था. Remember, I already told you it's the positive nature of this carbon that causes the reaction to happen. Okay, this reaction specifically. ठीक है? So I know there's more than meets the eye. इसलिए मैं बोला कि I've given you the reaction mechanism in the comments. यहाँ पे है, मैंने डाल दिया है. Check it out from there. We'll study this in detail when we do acids. Okay. And that's why 12th organic chemistry is so weird. It's all jumbled up, right? जब आप पढ़ते हो haloalkanes, you're studying reaction of alcohol. When you're studying alcohol, you're studying reaction of acids as well. So it's all together. So if something is a little complicated now, you'll understand by the end of all of it. And if you're impatient, you want to know right away, जाके देख लो क्या हो रहा है. आपको हिंट दे दिया है. It's this guy that causes reaction to happen. इसीलिए देखो मैंने यहाँ पे arrows draw किए हैं, which means these electrons go there because this is positive charge over here. ये यहाँ पे चला जाता है, you get a negative charge, and voila, you get this ester. And you'll be like, this is cool, yeah. This is the only place that has RO comes from here, and ये HCl leaves. So you kind of got the answer to the first one as well. Also, यहाँ पे अगर HCl acid बन रहा है, this HCl, अगर मैं pyridine डालूं, this speeds up the reaction. Pyridine is a nice base, nitrogenous base. ठीक है? Lastly, acid anhydride से भी बन सकता है. What is an acid anhydride? दो acid molecule में से पानी निकाल दो. ठीक है? Now it doesn't matter किसमें जा रहा है because it's the same molecule. Okay, that's an anhydride. And again, you don't need an acid catalyst. So this is anhydride. So I have RCOOH, and let's say I get another RCOH. If I take out water from here, I get an anhydride. Again, we'll study this in detail जब हम लोग करेंगे acids, aldehydes, ketones and all that. We'll study what's an anhydride, क्या होता है, क्या, and what, why not and all. Cool. And here with an alcohol, I get a milder acid which is easier to deal with. I don't have HCl, I don't have crazy acid, so this is much easier to deal with. And there's no need of any strong acid needed as a catalyst. There's also another good way to prepare esters. Okay. Yeah, the best ways of preparing this is using acid, acyl chloride या फिर acid anhydride. Okay. Any doubts here? Yeah. You don't need strong acid. That's awesome. And strong acid अलग रिएक्शन भी कर सकता है. देखो हम लोग हाइपोथेटिकल चीज कर रहे हैं, राइट? इट्स द इक्विवेलेंट ऑफ केमिस्ट्री, इक्विवेलेंट ऑफ फिजिक्स में फ्रिक्शन इज इग्नोर्ड, राइट? सो केमिस्ट्री में नाउ वी आर लुकिंग ओनली एट वन ग्रुप, बट इफ यू डील विद फार्मास्यूटिकल थिंग्स, देयर आर मेनी ग्रुप्स. देयर आर लाइक 5-6 ग्रुप्स ऑन वन कंपाउंड, एंड यू डोंट वांट टू मेस विद द अदर ग्रुप्स व्हाइल यू आर ट्राइंग टू फॉर्म एन एसिड, ट्राइंग टू फॉर्म एन एस्टर. फॉर एग्जांपल, एक यहां पे मैंने दिया है लास्ट थिंग फॉर टुडे, राइट? एस्पिरिन व्हिच यूज्ड टू बी यूज्ड एज अ पेन रिलीवर, सैलिसिलिक एसिड with acidic anhydride के साथ लोग रिएक्ट करते हैं ताकि ये वाला ग्रुप अफेक्टेड ना हो. ठीक है? We don't want to mess with that acid group. If you use a strong acid, then things could get weird very quickly. Okay? And right here, oops, sorry, you get acetyl salicylic acid, which is aspirin itself. ठीक है? Cool. That was the end of आज की कहानी. I know I covered a lot today, so please try and read NCERT. And again, if the esterification का mechanism is bugging you, please check it out. I gave you a hint already. It's basically the carbon का positive charge, not positive charge, is the nature, the bond, this bond, RCO bond, that is responsible for this reaction. Which means RCO आता है acid से, I'm giving answer already, and RO आता है अल्कोहल से. ठीक है? Esterification is nucleophilic substitution reaction. Okay, Medha, interesting. Is it though? All right, thank you for that. Nucleophilic substitution reaction. Nucleophile मतलब something that likes positive charge. All right, Medha. All right. Thank you, Ruby, for your time. And also condensation reaction, Medha, if that helps. As always, मजा आया इसको करने में. Organic में मजा आता है. I'm going to be doing 8:30 पे thermodynamics. If you want, check it out on the JEE channel. मिलते रहेंगे. Bye. See you around. Tata. If you like this, as always, share it with your friends.